So good evening and welcome to this presentation. My name is Mike Emery, and I'm the acting site administrator of Cornwall Iron Furnace, a historic site which is owned and operated by the Pennsylvania Historical Museum Commission, Pennsylvania's state agency for history. Our lecture tonight, he does it better, by Mike Weber is brought to you by the Cornwall Iron Furnace Associates, a nonprofit support group that is made up of volunteers from the community. Our lecture tonight will be a hybrid consisting of people in the room here at Cornwall Manor and people at home watching on their computers. For those of you attending in person, we will gladly take your questions at the end of the presentation. And for those of you on Zoom, please send your questions using the Q&A button, and we will address your questions at the end of that presentation as well. We're also recording this evening's lecture, and we'll place it on the museum's YouTube channel in the near future. And if you haven't looked at that channel, we have probably about 50 videos on there right now, many of which were presentations that have been given in this room, and have lots of different topics that are there. I was actually even watching one the other evening that we did when we were closed down for COVID, if we can remember back those 5 years ago, if we've already blocked those. And I was making cookies with my daughter, who was down here because she was, only 9 at the time. So she's now only a little taller than that, but older, and probably embarrassed that I mentioned that. So, but yes, go ahead and check those out. There's lots of great information, and especially now that we've entered into the cold and dark time in the season. There's lots of great entertainment, but also lots of good education that's on that channel. So I want to introduce tonight's speaker, Mike Weber. Mike is a popular returning speaker for the museum, and he has a long history and love of Cornwall. As a child, he collected rock and mineral specimens from in and around the Cornwall mine's waste rock piles, and that led him to the study of geology. As a 1982 geoscience graduate from Penn State University, Mike worked for 36 years as a geologist, health physicist, and manager for the U.S. Nuclear Regulatory Commission and the U.S. Geological Survey. After retiring from federal service, he returned to Cornwall, where he serves as a guide and researches the history of mining and geology of Cornwall and similar deposits in Pennsylvania. Thus, why we're having tonight's lecture. So Mike is a weekly volunteer at the museum and gives guided tours of Cornwall Iron Furnace on most Fridays. And he's also the author of Always More Production, a history of the mining operation at Cornwall. So please, I'd like to welcome our speaker this evening, Mike Weber.
Thank you so much, those of you who are here in the room at Cornwall Manor, and also those of you who are joining us live on Zoom, or those of you who will watch us sometime later when you see the recording of our presentation. I was so glad to hear Mike's exuberant shout of ore, because that's the real title of this program. Now, preface that by saying, can you imagine being out in cold weather like this? You're wet, you're dirty, you've been hacking away on the side of a hill for months on end, you have nothing to show for all of your efforts, and all of a sudden you hit pay dirt. Or, right? You're going to be so excited, so exuberant. So that's what this is all about. This is actually the third in a series of 4 presentations about the materials of Cornwall Furnace. So we started this series talking about slag, and now it's a waste product from the Cornwall Furnace and other charcoal furnaces. Then we talked about charcoal. This is the third in the series, talking about ore, the source of the iron for the furnace. And then if we do the last one, that will be on limestone. It may not be next year. It may be sometime off in the future, because I would expect next year we'll really be focusing on the 250th anniversary of our great country. So limestone, that's timeless. So that can be in 2027 or anytime thereafter. But we'll see. So this is one of the highlights for me to present to you. I always enjoy not only making the presentation, but doing the research, collecting the information to present, because my objective is to share with you in a fairly straightforward manner some of the history that we celebrate right here in Cornwall. Now, tonight's talk is going to be broader than just Cornwall, because after all, mining iron ore throughout the Commonwealth of Pennsylvania was a big deal in years past. And so my objective with you this evening is have you walk out of here saying, I never knew that, or, oh, that explains why that big hole is in the side of the hill that we always drive past. So hopefully you'll have that same exuberance with your reaction to this presentation. Now, I have to say that as I was preparing for this, one of my colleagues at the furnace, who has a tendency to speak rather directly, said in these same words, Mike, how are you going to make that interesting? So you will be the judge of that. And hopefully, if I'm successful, you will stay awake, and you'll also walk out of here knowing just a little bit more about iron ore in our great state. I want to begin by thanking Mike Emery, who's already introduced me. Besides acting site administrator, Mike is also the Eastern Bureau Chief of the Bureau of Historic Sites and Museums of the Pennsylvania Historical and Museum Commission, and acting Cornwall Site Administrator. We also have Lydia Jones, our museum educator tonight. So it's great to have Lydia and have her support. Bruce Chadbourne, who I'm sure most of you, if not all of you, know as a resident here, a researcher, a writer, just a great person all around. And then Kathy Donaldson, who's the treasurer for the Cornwall Iron Furnace Associates. And I appreciate all the support. There's a lot of work that goes into making these presentations successful. It's not just the speaker, but it's also the background work that has to come off well in order for you to join us here tonight in person or by Zoom. Also like to thank Cornwall Manor for allowing us to be here in the Freeman Auditorium. It's part of our history, and it's great to celebrate that. As I begin this presentation, I want to call your attention to the photograph that's on the slide. There's a lot of history in this photograph. This picture was taken by A.B. Parvin, who was a member of the Philadelphia Photography Society in about 1880. And it's one of the only pictures that we have in a mine underground in southeastern Pennsylvania in the 19th century. And the picture happens to be taken in an iron mine. I don't know if you can read the scrawl there at the bottom of the photograph, but I left it in because it really helps to understand what's going on here. So these miners and visitors are down at the bottom of a shaft, and they're at the 300-foot level in the Boyertown magnetite mine. And Mr. Parvin took 4 of these pictures. In the lower left-hand corner, you might just be able to make out flashlight. This is when they didn't have the nice strobes that we use today, but they literally used magnesium powder in a tray that was lit with a match. And that magnesium powder flashed bright white light. And that's how they took this photograph at 300 feet below the surface in the Boyertown magnetite mine. We're not sure which mine this photograph was taken, but I thought it was a good way to start out our presentation tonight. And it's also Veterans Day, so it would be remiss for me not to recognize and thank the veterans, those who served, people who sacrificed to support our country. Just today, one of our local residents found himself on the cover of the Washington Post. A man by the name of Russell Sadison, who's 99. I don't know if anybody knows Russell, but Russell was in World War II, so he's one of the few remaining veterans. And he was highlighted because he lost his right hand fighting in Germany, and he still is around, so he's telling the stories about his service to the country. And they also profiled other veterans that also served the country. So it's important that we give our veterans lasting gratitude for their service. So for the presentation on ore, after this introduction, I'll be defining ore because I think that may be a new term to you. We probably all used it in its common vernacular, but I want to highlight some of the aspects of what makes an ore, and that will feed into the rest of the presentation. I'll talk about the history of ore, talk about the iron ores of Pennsylvania in general terms, talk a little bit about Cornwall ore, because after all, the big granddaddy of them all is the Cornwall mines and the iron ore that was mined here for 236 years. And then I'll talk in a little bit more detail about mining iron ore in Berks County, not Lebanon County, but close by, because I think it gives you a better perspective about how broad scale and how widespread was this iron mining back, especially in the 19th century. And then we'll talk just a little bit about iron mining today, because we often get questions at the furnace. Well, if they're not mining iron ore here in Cornwall anymore, where is our iron coming from? And then, of course, I'll leave plenty of time at the end of my presentation for your questions and comments. So let's start by defining ore. Pull this out of the Oxford Dictionary. It features all the elements that I wanted it to, so that's why I selected this definition. It's a naturally occurring solid material from which a metal or valuable mineral can be profitably extracted. So first of all, note it's naturally occurring. We as humans can't make ore. Like slag is not ore. You might be able to recover valuable minerals from slag, but by definition, slag produced in a furnace is not ore itself. It also has to be solid, so that takes off the table gaseous materials, liquid materials. We're talking something solid. It has to contain a metal or a valuable mineral. So, for example, we mine a lot of sand because we use it in a wide variety of uses. But sand itself, or sandstone, like these walls, would not itself be considered an ore. And then, perhaps most importantly for this presentation tonight, you have to be able to profitably extract the metal or the valuable mineral in order to make it an ore. And I have a picture there of magnetite. Notice I haven't called it magnetite ore, because just a single chunk of rock or a specimen of a mineral isn't by itself an ore, because it has to satisfy all these different definitions. And those rocks on the table, while they are specimens of minerals that contain iron from Cornwall, they're not necessarily ore. So let me illustrate what I'm talking about. Well, Greenland's been in the news recently. And so Greenland, as you see in this map, contains a lot of valuable minerals, rare earths, nickel, zinc, iron, graphite, platinum, gold. The list goes on and on. They're shown in that map. However, most of those minerals are not profitably extractable. Why? Well, because among other reasons, there's a couple thousand feet of ice over most of Greenland. So if you wanted to extract the minerals that are present in the the Greenland, you'd have to get through that ice, right? And that's probably not going to be an inexpensive ordeal. And so that's one of the factors that adds to the cost of mining these minerals. Now, point out two things. First, mineral values fluctuate. We saw that recently with the rapid escalation in the cost of gold as a commodity, right? Gold crested recently at $8,000 per troy ounce. That's a big rise. So as those values rise and fall, that may make a mineral deposit an ore one day, but then in short order, if the value of that mineral decreases, it may no longer be an ore. So there's a temporal nature to this. And then the last point I'd highlight is building infrastructure in general can shift that level that makes it profitably extractable. So for example, if Greenland starts developing electrical infrastructure, deep ports, railroads, all these different features that may make some of the minerals that are present there today ores, or if the value goes up considerably, that may make some of those mineral deposits ore. But now let's take an example a little bit closer to home. Cornwall. A lot of our guests to Cornwall are surprised when they walk around the grounds at the Cornwall Furnace or nearby, and they see pieces of magnetite, iron, rock containing iron, on the surface. And they say, why is that rock sitting there? Why didn't somebody take that rock and use it productively and get iron out of it? There's also several million tons of magnetite in the ground here that remains at Cornwall. When mining ended on June 30, 1973, Bethlehem Steel had not removed all of the then iron ore that they were mining. There's also a lot of iron in the tailings, those residues that were produced. Some people call it schmutz, both here in Cornwall as well as in Lebanon. You could conceivably extract other valuable minerals and materials out of the tailings. And then there's all the red sandstone, which we see in this beautiful wall right here, right? It's red because it has a trace amount of iron in it. But because there's so much red sandstone, if we could somehow process all that, we could recover iron out of that. But it's not profitably extractable. So therefore, it's not ore. The history of ore evolved over the millennia. It really tracked the development of what we call today the modern field of mineralogy. So just to highlight a few things, during the Iron Age, writers started describing mountain ore and bog ore. We'll talk about bog ore a little bit later on. And then Pliny the Elder in 50 Common Era in Rome talked about magnetite, jarosite, another source of iron. Then you have perhaps the most famous of the ancient writers, Agricola, who wrote Re de Metallica, talking all about the nature of metals and how do you mine it and produce it profitably. And then you have the founder of modern mineralogy. So this is how ore came into existence, recognizing that it's this concentration of valuable minerals. In the upper right-hand corner, I have a photograph of two pyrite crystals from one of the early mineralogy texts from Pennsylvania. Pyrite and Cornwall have been famous for hundreds of years here at Cornwall. This map from Knowles in 2013 depicts both the relative location of iron ores as well as coal deposits in the eastern half of the United States. So for the iron deposits, there's the yellow, and those are the iron carbonates. Don't worry, we're going to get into this in more detail. There are magnetite deposits, There are hematite, and then there's something called brown. We'll talk more about what brown ores are, but for the sake of illustrating in this map, you can see that those iron ores are pretty widespread. Now, perhaps they're using ore here a little broader than what we might use it as, because we don't know whether these could be profitably extracted or not. You'd have to deal with that on a case-by-case basis. Here's another map from about 1880 in Pennsylvania, and they were highlighting at this time those ores that were of most interest. And you can see Cornwall and the other iron ores are depicted in those little red squiggles that you see throughout the state. And they're pretty prolific, all the way from the east to the west and south to the north. You can also see the anthracite coal deposits there depicted in blue in the northeast. You can see the petroleum deposits in the northwest around Drake's Well. And I don't know if your eyes are super powerful, but if they are, you can find some little orange dots, which were the principal zinc deposits in the Commonwealth. So again, you're getting the impression, okay, looks like there's a fair distribution of iron and some of these other minerals and petroleum. So before I proceed, let's get grounded on some basic terminology. First of all, the three rock types. You've got sedimentary rocks. Those are rocks made out of either chemical deposits or mechanical deposits where the deposition occurred in water or air. You have igneous rocks. The rocks solidified out of molten rock. And then there are the metamorphic rocks, where the sedimentary and igneous rocks have been subjected to more heat and pressure, and that's changed the rock and its structure. And then the principal iron minerals, I'd call your attention to magnetite, especially important for here at Cornwall. 3 atoms of iron to 4 atoms of oxygen, Fe3O4. And magnetite can be as much as 73% iron. We talk about the ores here at Cornwall as being mined up to about 60%. That's what they found here. So those were high-grade ores of iron. The hematite, Fe2O3, up to 70% iron. Limonite, these are the brown ores, and we'll talk about them in more detail. These are iron oxides, and they've been hydrated. That means there's water molecules that are attached in the chemical structure of the ore. And they're a little less than magnetite and hematite, can be up to 60%. And then there's siderite. Siderite is iron carbonate, FeCO3. Excuse me. And siderites are, of these minerals, the least concentrated of the iron minerals. Now, the 5 basic types of iron ore in Pennsylvania. They're the magnetite, hematite ores in igneous and metamorphic rocks. We'll go through these in one at a time. There are the brown ores and also surface deposits. There are siderite ores that are found, iron ore with the coal deposits in the state. There are hematite ores that are found in sedimentary rocks. And then there are the Cornwall type ores. So yes, Cornwall is so important in geology, mineralogy, that it got its own category of iron ores. And we'll see where else in the state you can find Cornwall type ores. So let's start with those crystalline, magnetite, and hematite ores. These principally occur in Pennsylvania in ancient rocks. Now, by ancient, I mean rocks that are typically older than 500 million years, 500 million years. And they're often found in metamorphic rocks called gneisses, principally in Berks County, Lehigh County, Berks, and Northampton counties. The ores typically we averaged about 45% iron. And you might expect that we don't just find pure iron out in the environment. So it's often mixed with other minerals and chemicals. In this case, silica dioxide, is a principal contaminant or impurity in those ores. And that's important because if a iron mineral concentration has too much of these impurities, it could actually prohibit the use of that material as an ore, especially in an iron furnace. They're found in igneous to metamorphic rocks. Thanks, Mike. What's in that? Or it's a hydration, right? Hydration. Thank you. These ores were mined as early as 1698 in Pennsylvania. That's pretty early. Now, remember, Penn received his charter for Pennsylvania in 1681, right? So shortly after that charter was granted and people started moving here as part of that, they started mining iron ore close to Durham Furnace. Durham Furnace only began operating in 1727. So it leads you to wonder, what were they doing with the iron ore before they started feeding it into the furnace? That's one of those history mysteries. Most of the active mining of these ores occurred in the state between 1870 and 1895. And some of the typical localities you think about are Seiss-Holtzville, Veracruz, Durham, and Rittenhouse Gap. And when you take all of the mines and you stack them up that were mining this kind of iron ore, they produced more than 1 million tons of ore. So that's a lot. But again, it's a lot of little mines stacking up to amount to that more than 1 million tons mined, as compared to Cornwall, which we'll compare it against later. Now, one of the particular ore deposits is the Marctic magnetite and specular hematite. So these occur in old shales in York and Lancaster County. Particularly the metamorphic rock called the Harper's Phyllite, and the sediments that make up that rock were originally deposited about 500 million years ago. These rocks, if they're ores, contained up to 50% hematite and 10% magnetite. Because that amounted to less than 36% iron, they typically had to use magnets to concentrate this ore to boost the iron concentration up before they fed it into the furnaces. Most of the mining took place between 1854 and 1903, and altogether amounted to over 100,000 tons. Less than the prior category, but still a significant amount. Then we have the brown ores, or residual limonite ores. These ores form from the weathering of other metamorphic sedimentary igneous rocks, typically from pyrite that broke down, or iron silicate minerals, or iron carbonate minerals like siderite. And this principally occurred during the late Cretaceous to early Tertiary. That's about 65 million years ago. So younger than the rocks that we were just talking about, but still significant. The ores in this category ran between 35 and 50% iron. And now, in addition to silica as an impurity, they also sometimes had elevated levels of phosphorus, manganese, and zinc. Why is phosphorus important? Well, when they first started producing steel on an industrial level using the Bessemer-Kelly converters, if there was too much phosphorus in the iron, they couldn't use that iron. So the ores that had lower concentrations of phosphorus, like less than 0.2%, became the premier ores because they could use them in a wider variety of furnaces at the time. Some mines, I should say, in terms of the scale of these mines, there were hundreds of these mines in various counties: Lehigh County, Berks County, Lancaster, York, Cumberland Center, Huntington, and Mifflin counties. These were abundant mines. Today, when we drive around, we have no perception of how prolific mining was in Pennsylvania because we don't even think about some of these areas as well-established mining communities, and yet they were. Some of the mines produced ochre. Ochre is an iron oxide that's in like a fine clay. And that ochre was mined and then it was used as a paint additive to color paints. It was also used to color paper. And so lots of ochre mining occurred here in conjunction with the mining of these residual limonite ores. Annual production, now not total production, but annual production exceeded 1 million tons during the peak years that these mines operated, from about 1865 to 1880. And the last significant production of these kinds of ores occurred at about the end or middle part of World War I. So for all intents and purposes, these ores were pretty well played out in Pennsylvania by 1915. On the right, you see two different pictures, limonite, which is the most common of the brown ores, and then goethite is in the lower picture there, just a beautiful couple specimens to show off what these rocks look like, or minerals. Now, to give you some idea of the scope of these operations, I show three pictures. The uppermost picture, the Shawnee furnaces in Lancaster. These furnaces were operated between Lancaster and Columbia. They were large operations and they were fed using brown ores that were being actively mined across that entire extent. In the picture on the right, the Scotia washing mill, these were iron ore deposits that were mined in Center County, Pennsylvania. Carnegie was one of the earliest investors and developers of these deposits in Scotia. And that's a washing mill. So this factory was set up to wash out clay and other soil to separate it from the iron ore that then was concentrated and sent off to the furnaces. And then in the bottom picture, you have Macellum Mine. That's in Berks County, the largest of the limonite mines in Berks County. You can see it's a large pit, like our open pit here at Cornwall. And of course, it filled with water once the mining ended. There's also a particular subcategory of these brown ores, and that's called bog ore. One of the earliest furnaces to operate in the United States, or the predecessor of the United States, the British colonies, was the Saugus furnace outside of Boston, Massachusetts, and they used boghorn as their source of iron to feed the furnace. So these are ores that are deposited in bogs, marshes, and also shallow lakes, really over the last couple million years. That means that bog ore is forming as we speak. So this is a renewable source of iron. That is, let's say you extract the ore out of a marsh. The marsh grows back. You come back 50 years later, you might be able to extract more bog ore from that marsh. These were especially common in northeast and northwestern Pennsylvania, largely in the areas that have been glaciated in the state. And most of these deposits are relatively small. That means the most you're going to get out of one of these deposits is usually less than 1,000 tons. Much smaller than the limonite mines we were just talking about and the other types of ore deposits. And I didn't mention it, but the type of ore, it's a brown ore. So we're talking about impure hydrous iron oxides, limonite, but it also is going to contain vegetable matter from the root structure and the plants that die. It's going to have silt and sand in it. So there might be an impurity problem with your bog ore unless you really process it. Then there are the iron carbonate ores, the siderite ores. These were found in sedimentary rocks that were deposited back during the Pennsylvanian period, about 300 million years. I'm rounding so you get a general idea of the age. They were formed in rocks that are co-located with the bituminous coals in the western part of Pennsylvania. Some of these iron carbonate deposits were found in the anthracite coals in eastern Pennsylvania. These are less concentrated than the magnetite and hematite, typically up to 30 or 40% iron. If the siderite weathers, it can boost the iron concentration by dissolving out some of the carbonate and leaving behind some of the iron minerals. Phosphorus and silica are common impurities. Most production from the siderite ores occurred between 1825 and 1855, and mining was largely done for these ores by 1900. We really don't have good information on how much siderite ore was produced in Pennsylvania, principally because they were mining the ore in conjunction with areas where they were mining coal. And so coal was the big mining objective in these areas. And if they got some iron ore along with it, great. But they really didn't keep good records, at least that we have access to today, about how much siderite ore they were actively producing. There are the sedimentary hematite ores, so-called Clinton-type ores. These are also known as fossil ore or block ore. They were deposited in sediments that were being deposited in a near-shore environment, shallow marine settings. They're distributed across central Pennsylvania in different rock units called the Lower Silurian Clinton group, hence the name Clinton-type hematite ores, the Middle Devonian Mahantani Formation, and the Upper Devonian Lock Haven Formation, about 400 million years, plus or minus 50 million years. Up to 20 to 50% of these rocks could have iron minerals in them. And typically the iron was deposited as coating on shells, hence the reference to fossil ore, or around sand grains that washed up the beach and then washed down the beach and then washed up the beach and washed down the beach. And as they went up and down, they slowly acquired more iron oxide on them, more hematite. And then when they became rock-like, lithified, that was preserved in the sedimentary rock. Phosphorus can be the most objectionable impurity in these ores. The mines produced more than 5 million tons between 1840 and 1885. So if you hear talk about the iron ores of the Juniata Valley or the Clinton ores, you go right past one of the mines that mine this ore when you're on the Pennsylvania Turnpike, when you're out near Bedford, Pennsylvania. These were fairly extensive as you travel about. And then one of our favorite, the Cornwall type ores. Picture on the upper right from Cornwall in about 1910, and a sketch of a typical magnetite Cornwall ore that was in one of the Pennsylvania State Geological Survey books. These ores were formed along the contact of an igneous intrusion, in this case Jurassic diabase, sometimes referred to as trap rock, and limestone or dolomite. And so the intrusion occurred about 200 million years ago, so these ores are younger than 200 million years. Magnetite is the principal iron mineral, along with other iron minerals like hematite, pyrite, chalcopyrite. Iron concentrations up to 60%, more of a typical average is around 40%. Just at Cornwall alone, they produced 106 million tons of this ore. So that's the biggest chunk of that 150 million tons. When you add the 48 million tons that were mined at the Grace Mine at Morgantown, that's about 150 million tons. So those two mines alone accounted for most of this 150 million tons. Because mining extended here at Cornwall from 1737 until 1973, you have an extensively long duration of mining. Peak production occurred in 1940s, 1950s. And the Cornwall mines were the largest iron mines in the United States until the late 1880s. So we have a lot of history to celebrate here at Cornwall. give you an idea of the distribution of these ore deposits, they're not just at Cornwall. This map shows that they exist in an arc that extends from Gettysburg along the southern border with Maryland up to basically close to the Delaware Water Gap along the Delaware River. The geologists have broken these out based on where the ore resides as compared to the intrusion, the diabase, the trap rock. And so they distinguish the Dillsburg deposits separate there in the lower, left-hand side of the arc. And then, of course, you have Cornwall, which we're sitting in right here. There's the Wheatfield Fritz Island deposits, which are close to Reading, Pennsylvania. Then there's the Morgantown French Creek deposits. There's the Boyertown deposits. That photo that I showed you on my title slide was in one of those Boyertown mines. And then there's Pine Creek. Pine Creek is an iron ore deposit that has not been mined. So you might question, well, does that mean it wasn't profitably extractable? Right? Going back to our definition of ore. Anyway, if you're interested, it sits there a couple miles to the west, I believe, of French Creek. So maybe there will be more iron to come. Show you an operation. This is one of the mines that produced iron ore from the Dillsburg area. This happens to be the Logan mine in Carroll Township in northern York County. This photo was taken in 1878. You can see there's about 20 miners there. So these were small-scale operations, much smaller than here at Cornwall. The ore deposits were scattered across a larger area. The mines in the Dillsburg district principally produced between 1855 and 1915. Cornwall stimulated a lot of interest. Everybody wanted to strike it rich like Cornwall. And so that prompted a lot of interest in prospecting for these ore deposits. And that's what helped to develop them. Total production from the Dillsburg mines was about 1.5 million tons of ore. Contrast that to the 106 million tons of ore from Cornwall. Cornwall mines. In the upper photograph, you can see the ore standards, and they were cut as 1 foot cubic blocks about 1860 to teach the miners how to distinguish by sight the different grades of iron ore that they were mining at Cornwall. They weren't using fancy analytics. They weren't measuring specific gravities. They weren't doing iron chemistry. They were teaching the miners, hey, if it looks like this and it's about this heavy, that means it's a type 1 ore. That's good ore. Go after that ore. If it looks like this, we'll still take it, but it's probably a type 3 or not as good. But that's how they were able to transfer that knowledge to the miners so that the miners could do their jobs. Of course, it's here in southern Lebanon County. The ore that was mined was mostly magnetite. In the specific case of Cornwall mines, the iron ore replaced parts of the Buffalo Springs limestone along that contact with the trap rock or the diabase. The ore was described as massive, bedded, weathered. Some of the ores, a lot of the ores, as it turns out, contained elevated amounts of sulfur, so they had to roast those ores. And if you've ever been to the Cornwall Furnace, you've come down our pathway into our parking lot. Off to the left, you see that early roasting oven. That was one of the early attempts to use heat to drive off some of that sulfur before they put that treated ore into the furnace. Other ore minerals that existed were hematite, pyrite, chalcopyrite, pyrrhotite, another iron sulfide. Magnetic concentration had to be used from 1905 on to keep the Cornwall ores competitive. At the surface, when they started mining, the iron deposit had been weathered, so the more soluble minerals had washed away over a long time, leaving behind a higher concentration of iron. As they dug through that weathered zone, they got into fresh ore. That fresh ore had more sulfur, and it also had other minerals present, and that meant that the iron concentration decreased. So they had to use magnets to reconcentrate the ore to make it competitive for use in the furnaces. There were two primary ore bodies that were mined. We'll see that. Ore was excavated from 5 mines. That's why when I talk about the mines of Cornwall, I'm always referring to it in the plural, because you had the Big Hill mine, the open pit mine that was below Middle Hill and Grassy Hill, the number 3 mine, which was an underground mine underneath the floor of the pit, and then the number 4 mine, which was further east, mine, the east ore body, all was below ground. And then there was the Elizabeth mine in between Big Hill and the number 4 mine. That Elizabeth mine produced ore that was used at the Elizabeth Furnace way back in the 18th century. And then, like I mentioned already several times, Cornwall produced 106 million tons of ore, along with other metals that were present in trace concentrations, including copper, silver, gold, cobalt. And then they were also able to recover sulfur because they were processing the pyrites, so they were able to extract the sulfur as sulfuric acid. I'm not going to get into the detailed geology because that would violate my objective of covering a lot of material at a high level. But I wanted to show this diagram. This is out of Geology of Pennsylvania. It's a great book, special publication number 1, published in 1999. It's thick, so there's a lot of good information in it. But you can see on the map, outlined in the 2 black lines, the main ore body, which was to the west, and then the eastern ore body, which was mined by the number 4 mine to the east. Production from Cornwall really took off once the Cornwall Ore Bank Company was established in 1864. You can see before that, from about 1737 until that date, there was mining going on. It just didn't amount to much in comparison to what they were able to extract once they improved the organization, the productivity, and the industrialization of the mining operation. And then most of the ore was recovered when Bethlehem Steel operated the mines from 1916 until the mines closed in 1973. And each of those dots that make up this curve are annual production amounts. And by accessing the records, we were able to produce this chart. Cornwall mines today, your Cornwall residents, you're already probably familiar with us, but for some of the people joining us perhaps remotely, they may not be as familiar. Probably the most prominent landmark that we have of the mines today is Miners Lake, the backfilled open pit, about 450 feet deep in the deepest places, and now filled with about 300 feet of water. You have the 3 hills north of that open pit, Grassy Hill, Middle Hill, and then Big Hill off to the east. Cornwall Furnace right there in that saddle between Big Hill and Middle Hill. And then the number 3 shaft on the north wall in the western end of the open pit. And then a half mile to the east, you have the number 4 mine featured here by the number 4 and the number 5 shafts that access that mine. Let's shift now to Berks County because, as I said at the outset, it's a good overview of just how prolific mining was. So between 1727 and 1977, there were more than 178 iron mines in Berks County alone. What I plot on this map of Berks County are the mines that produced at least 100,000 tons of iron ore at some point during that period. Redding is, of course, that blotch in the middle of the map. And then you have the Cornwall type mines, the mines that were mining the Cornwall type iron ores with those blue hexagons. The limonite sourced mines were the brown triangles, brown ore. And then the other magnetite mines, other than Cornwall type deposits, are the green circles. And the source of this information is from Sloto 2016. And I'll end my talk talking about that. So let's look now at some of these mines. The Jones mine, located just outside of Elverson, Pennsylvania, mined iron ore from 1773 until 1886. It was a Cornwall type iron ore deposit. It's estimated that this mine produced over 500,000 tons of iron ore. In addition to the iron, they also found a lot of copper mineralization, but the copper mining was never able to make a profit here at the Jones mine. So while they made profits selling the iron ore, they couldn't process enough of the copper ore cheaply enough, so it didn't meet that definition of ore. This picture is of the Jones mine in the 1880s. And I want to call your attention to the fact of two things. One is that large incline that you see. We have an incline just like that in the open pit, the number 2 incline. But they beat us by about 30 years here at the Jones mine. This picture in the 1880s, that hoist is well established. The other thing I'd call your attention to is the appearance of the ore in the lower right-hand corner of that photograph. It looks just like that ore specimen that was sketched that I showed previously. Only in this case, you're looking at a whole wall of an open pit, not an individual specimen of ore. And of course, what you're seeing here are the layers of limestone, the beds of limestone that have been replaced with the iron mineralization. So you have magnetite, then you have less rich ore, and then you have another high band of magnetite, et cetera. And that's what gives that alternating layer effect. Eckert Slope. This is a mine in Boyertown, Pennsylvania. Eckert Slope began as an open pit, and then as it continued to develop, they started doing deep mining, operated from the 1850s till the 1870s. This too is a Cornwall type deposit, and it's estimated that this mine produced about 600,000 tons. The photo was taken in the 1890s. As you see, mining had already stopped and the surface pit had flooded by the time the photo was taken. This is the Udre mine. This provided limonite ore in Roscommon Manor Township. If you look on the right side of this topographic map, you might be able to make out the Ole Furnace. And so this mine produced iron ore that was intended to be used at the Ole Furnace. Ole Furnace operated about the same time as Cornwall Furnace, but not as long, not as prolific. So this mine operated from the 1790s until the 1880s. Because of the other minerals that were present, it was ultimately deemed not suitable for use in the Ole Furnace. And so they sent these ores about 9 miles away to Temple, Pennsylvania, where they were used in the Temple Furnace. And if you could make out on that topographic map, you're looking at a ridge, of course, and the Udre mine is on the top of that ridge. But all along that ridge are other iron mines. So you can see how extensive the ore was distributed along that ridge. And of course, the miners knew it, and they developed additional mines to recover the ore. Total production from this mine was about 640,000 tons. And then there's runner-up number 1, the Grace Mine, this being in Morgantown, Pennsylvania. Operated from 1952 until 1977. It's again a Cornwall type deposit of ore. 45 million tons of ore were mined from the Grace mine. The ore never cropped out at the ground surface. So most of the ore that was mined at the Grace mine was mined below about 2,200 feet below the ground surface. Grace Mine was developed by Bethlehem Steel, and they used the technology, both the mining technology and the iron concentration technology that was developed here at Cornwall. In fact, for a number of years in the early operation of the Grace Mine, Cornwall Division was the managing organization that operated the Grace Mine. Most of the ore from the Grace Mine remains underground. And you can see I have a little cross section of the geology on the upper right-hand side of that map. So you see the magnetite ore is that buff colored in the middle, sandwiched between Triassic sediments above and then the diabase or the trap rock below. And that scale in feet goes from 500 feet below the ground surface down to 1,500 feet below the ground surface. So where is iron mining taking place today? In the upper left-hand corner, we have a diagram showing by relative size of the circles the amounts of iron ore that was produced. As you might imagine, these total production rates change year to year based on economic market conditions, et cetera, world trade constraints. In the lower left-hand corner, I have the top 4 producers as of last year. So Australia was number 1 with 866 million tons. Brazil number 2 with 390, South Africa 61, and then India 38. Just to show you the scale of these operations, the upper right-hand picture is a picture of Fortescue in Australia, and all you see is iron ore in that whole picture. On the left is a truck convoy hauling iron ore, and on the right is a train hauling iron ore. So the scale of these mining operations is immense. They're producing in a year 8 times what Cornwall produced in 236 years. So it kind of puts things into perspective. And Brazil's also, keeping up with the company here. You see the picture in the lower picture from Brazil. And again, you see a rail train filled with ore cars, and they're taking the ore out to a port that's there off in the Atlantic. So again, just immense operations. And I just heard earlier this year, a new deposit of iron ore was found in Australia. And I think the estimated value of the ore was $7 trillion or something like that. Now, that's presuming it can be profitably extracted. So we'll see. Time will tell. Oh, went backwards. So I wanted to thank you for your attention. Hopefully you know a little bit more now about iron ore and its use in how it was produced, how it was mined. I promised that I would call attention to this book by Ron Sloto, The Mines and Minerals of Berks County, Pennsylvania. Ron was a fellow hydrogeologist. He worked for the U.S. Geological Survey, and now I understand he's the curator of and a professor of the collection at Westchester University. So if you're down there and you're checking out the minerals and you see this guy walk up, and you can say, "Hey, are you Ron Sloto?" You'll know all about it. So with that, let me bring it to a conclusion, and I'd be happy to answer questions or listen to your comments. So we'll start here. Yes, sir.
At the Grace mine, most of the ore was down so deep. How did they discover it?
Good question. The question was, how did they discover the ore at the Grace mine if it was so deep? Unlike here at Cornwall, where it was really at the surface. The deposit at Grace Mine was found using an aeromagnetic survey. During World War II, the U.S. military got well skilled on the use of aeromagnetics looking for submarines. And so after the war, they were able to apply that technology. And in 1949, they found a huge magnetic anomaly right there north of Morgantown. They started purchasing the property using I think it was called the Berks County Trust. They acquired 1,500 acres of farmland before Bethlehem Steel announced that, yes, indeed, they're looking to develop an iron mine here. They drilled a borehole in 1951. And right before the end of the year, they hit about 400 feet of ore in that borehole. So they probably shouted, "Ore!" I think some top-level executives drove down from Bethlehem Steel that night from Bethlehem and celebrated with the geologists who were on the mining crew. Now, that's the good story. The rest of the story is that having found one hole with ore, they drilled the next hole, no ore. They drilled the next hole, no ore. It took them about 2.5 years to actually map the deposit because it was at a weird angle. And if you weren't on the deposit, you weren't going to find ore. And so by 1953, they had done what they needed to do, and they had confirmed that there was a large deposit there. And so they invested the money to develop that body because they concluded they could profitably extract that ore. Victor?
I was doing some genealogy. Turns out that somebody in my family that lived in Minnesota was told that the Mesabi iron in that area was the largest in the world, according to Wikipedia. My question to you is, do you have any familiarity or comfort to talk about Mesabi?
Yeah, so his question is, after some explanation, am I comfortable talking about Mesabi? Yes, I'm comfortable talking generalities about Mesabi, but not specific mines, because that would take a lot more research. So he said, according to Wikipedia, Mesabi was the largest iron ore deposit in the United States. That's true. So there you go. Wikipedia comes through. Now, they mined Mesabi in a lot of different mines, and there are different parts of the Mesabi deposits. But when you added them together, they outpaced the production from Cornwall. And that's why Cornwall mines were the largest iron ore mines in the United States until the 1880s, because they were overtaken by the mining operations in the Mesabi Range. The other benefit with the Mesabi Range is they were able to transport large amounts of the ore by ship on the Great Lakes. And they brought a lot of that ore to Pittsburgh and to Cleveland. And so the iron industry, steel industry shifted west, principally because of the Mesabi Range.
My second question is, could you explain to us commoners a little bit about rare earth minerals? Because it seems our president is very interested in rare earth minerals.
Okay, so I'm probably not the person to answer that question. I know the question's about, could I explain in layman's terms about rare earth minerals? So rare earths are a subcategory of the elements on the periodic chart. They are very much in demand today to produce many of the technology leading components that we're using, like computer servers, lithium ion batteries. So they're elements like scandium, tellurium, things that we don't talk about on a daily basis, and that's what makes them rare earths. China has a large amount of these rare earths where they can profitably extract them. But we have a large amount of those rare earths too, if we're willing to pay the price to develop the mines to extract those minerals. But in a global economy, we want to compete. And it will be difficult to compete if we have to pay more for our rare earths than we could import them from other countries. So that makes rare earths a bit of a bargaining chip between nations when they're trying to negotiate trade agreements and other things like that. So I don't know if I've hit the nail on the head for you, but yes. Let's see, I saw one back there.
Do you know how many total mines there were in Berks County?
How many total mines there were in Berks County?
You said there were a number of.
Well, yeah, my map, I think showed 178 iron mines, more than 178 iron mines. But then in addition to the iron mines, you have other mines like limestone quarries, sandstone quarries, other metal mines. So I don't know the total number, but I wouldn't be surprised if it was at least 300 mines in Berks County. You don't know that today because you really don't see them anymore. But you do still see the remnants of those mining operations, especially if you use certain kinds of remote sensing techniques, which really highlight the pits that were dug. Then a lot of that land has been redeveloped too. So that also kind of overwrites the mining operation.
You mentioned limestone mine in Northwest Springs. Are you referring to the village along 419 and you go out to Shakerstown? Buffalo Springs.
Yes.
Is there the remains of a mine?
No. Yeah. So he's asking, is there a limestone mine in Buffalo Springs? And my answer would be no. But the limestone unit, the rock, is referred to as the Buffalo Springs limestone because it was first described in detail near Buffalo Springs. And so back in the day when geologists were traipsing around Pennsylvania trying to figure out what kind of rocks we have and how are they structured, et cetera, if you were the first person to describe a rock unit, you could call it based on where you found that rock and described it in detail. Now, later, it required a lot of coordination between geologists to figure out, is my Buffalo Springs formation the same as the Beekmantown limestone and other things like that, so that you could map that rock unit across the state or large parts of the state. So there are probably small pits and quarries in the Buffalo Springs formation, which you might refer to as a mine close to Buffalo Springs. But there had to be enough surface exposure so that the geologist that originally described that rock could see enough of the rock to describe it. You want to add anything to that? No?
So it's called Buffalo Springs limestone.
Yes.
Certainly found Buffalo Springs.
It can be found in Buffalo Springs, but they didn't mine it in large quantities in Buffalo Springs.
Just a second question. You talked about the copper that's being found, but it wasn't worth farming. So what they do?
Well, they couldn't make a profit from it. So this is at the Jones mine. They did, so the question was, what did they do with the copper that they found at the Jones mine if they couldn't sell it and make a profit off of it? They did invest money and they developed the mine, but that company could never make enough money from selling their copper ore. And they sold their copper ore, but they didn't make enough money back to pay the cost that it took to extract that copper ore from the ground. So eventually that company went bankrupt and a sheriff's sale occurred and people bought the property and the mining equipment through that sheriff's sale. Yes.
Types of iron affect the grade of the point environment.
Are you asking, so his question is, do the different kinds of iron ore affect the grade of the final iron metal that comes out from the use of that ore? If you had asked me that question and I represented the Cornwall Ore Bank Company in 1873, I would have said absolutely. But that was before we had modern metallurgy and engineering and so forth. So today we're able to take a large number of different kinds of ores of different grades and process them in a way that we can accomplish a standard for a particular kind of metal. So it's less of an issue today than it was back in the day. Cornwall Iron had a great reputation. Lots of people like to use it for producing nails, for example, because they said you can't beat a Cornwall nail. And what they were referring to were nails that were fabricated using iron ore from Cornwall. Maybe that's true. I don't know. But that was the reputation that we came up with.
I'm going to assume that mining as an industry no longer exists in Pennsylvania. So I'd ask you hypothetically, if there was still an infrastructure, steel making industry.
Wow. So his question is, would mining in North America still be, for iron, still be profitable if our steel industry was still going strong in the United States? And I would look at the history, because if you remember what I talked about with the Grace mine, they left most of the ore in the ground at Morgantown. And that's because at that time, it was less expensive to import the ore from overseas than it was to mine the ore out of the ground in Morgantown, process it, and feed it to the furnaces. Now, was the financial condition of Bethlehem Steel at the time starting to erode their ability to keep up with international competition? Probably. So that's a factor that's difficult to quantify. But I suspect that today, even with a booming iron industry, it would be less expensive to import from overseas. You saw the scale of those mining operations in Australia and Brazil. We just don't have ore like that in the United States anymore. So with the advent of modern transportation technologies, networks, global financing, I think it would be hard to make a go of mining iron ore in Pennsylvania, certainly, in today's environment.
Mention that five mines
Yes.
It's not familiar with that. Say they were mining there and then taking it to Elizabeth Furnace.
Yes.
By Bridgerville.
Yes. Is that your question?
Yeah.
Okay. So his question deals with the Elizabeth mine, and were they mining ore at the Elizabeth mine and sending it down to the Elizabeth Furnace, which is just north of Brickerville? And the answer is yes. That's probably how Robert Coleman became familiar with Cornwall because you remember, was operating the Elizabeth Furnace, let's see, right after the Revolutionary War, and sourcing his iron from the Cornwall deposit. And I'm speculating, I don't have any written letter from Robert Coleman attesting to this. But that may be how he became more familiar with operations at Cornwall and set out to acquire the Cornwall ore deposits. Now, years later, when the mining was being conducted by Bethlehem Steel in the 20th century, they went back to the Elizabeth mine and remined it because there was ore that remained. And that ore in the Elizabeth mine was right outside the concentrator plant, the new concentrator plant. So that's why when you walk across the landscape, you really don't notice where the Elizabeth mine was located. But they pulled another 300,000 tons of ore out of the Elizabeth mine between 1960 and 1962. And they did that when they were needing to augment the production from the Cornwall mines because they were doing some rework and maintenance repairs on the number 4 mine. So to maintain their productivity, they started mining the Elizabeth mine again. If you, well, I don't know if you could still see it today. You could see it, you could see the scar on the side of the hill, on the backside of Big Hill, up until probably March. But with the reconfiguration of the land surface back at the number 4 mine, I don't know that you could still see it anymore.
So was the mine owned by Grubb, or
It was owned by Elizabeth Furnace. It was not owned by Peter Grubb. It was outside the Clark Survey. If you're familiar with the history of Cornwall, at one point they tried to bound the extent of the deposits. And so the location of that Elizabeth mine was outside to the east of the Clark Survey line. So we have deeds that go back to Elizabeth Furnace that talk about the ore tract. And as best I can tell, what they were talking about is the ore that was at the Elizabeth mines. I don't know if you want to. Nope.
I'm not sure what the term, but Pennsylvania has never. In other words, if I own a piece of property, I don't like to give off the surface, which just underneath it, and everything below, and if I sell my.
Right.
And I only bring it up because the concern that's occurring because of oil fracking. But it was come underneath your land and suck you dry, and you have no right to the financial benefit.
Yeah.
That's what I think they refer to as severed rights.
Yeah. Severable rights.
Not some.
Yeah. Severable.
So, you know, all laws repeated.
Yeah. So I'm not an attorney and I'm definitely not a land attorney. But my understanding is we have severable mineral rights. I know the homeowners in Miners Village, for example, when they acquired their properties through sale from Bethlehem Steel maintained the mineral rights below the land. And that is now a problem, as I understand it, because people want to know, well, is somebody going to mine underneath my house? And so when they go back to clear the deed, there is no Bethlehem Steel entity to work with to get that cleared up. So.
I just start bringing it up. It did present problems in the High Valley area, Jersey City, because there were mines there that thousands, you know, so much water in them that all over Saucon Valley could build a house.
Yeah.
And this will not stop because the line didn't stop.
Right. So his example was the Friedensville zinc and how extensive the mining was and how much water they were producing out of the mine to keep the mines dry enough so that they could operate them, and how sometimes houses could just disappear into sinkholes or collapsed shafts and tunnels. And yeah, that is something that has to be attended to. But I don't know that that's an issue here at Cornwall. Because the land that the number 4 mine is underneath is the Iron Valley Golf Club. And the land that the number 3 mine is underneath is the open pit, which is filled with water and owned by Elizabethtown as their backup drinking water reservoir. So except for occasional occurrences that Mike's aware of, where maybe there's a deep drainage ditch or something that was backfilled years ago, and now all of a sudden the land starts collapsing into that ditch, you know, that can be a problem, and we have to deal with it. Yes, sir.
Just a couple of questions.
Okay.
So this is very timely. Thinking of the 50th anniversary commemoration of the Edmund Fitzgerald hauling taconite, was taconite ever produced from ore processing around the Cornwall area or nearby?
So the question from one of our online participants is, was taconite ever produced from Cornwall? And the answer is no. Taconite's a very specific ore. It's a hematite ore. It's interbedded with jasper, silica. So they didn't have that here at Cornwall, so they never produced a taconite ore. Now, they did borrow from the technology that was being used to process the taconite ore into the iron concentrate that was fed into the furnaces. And that's what gave rise to the creation of those little iron pellets that were manufactured using a Bethlehem steel designed process at the Lebanon concentrator beginning in 1949. But that's separate from mining taconite.
So, and just, I'll do one more final question. Are they still mining iron ore in the Midwest of the United States?
So the question is, are they still mining iron ore in the Midwest in the United States? Not on a very large scale. There has been, in the last several years, a renewed interest in mining in the Mesabi Range. I believe some of the mines in the last several years have been acquired with the intent to reopen those mines and resume production. So that's why I would say yes, on a small scale. Whether or not those companies can arrange the financing necessary and obtain the permits that will be required remains to be seen. But there is interest. So, okay. Our geologist has an question here.
Absolutely.
From Billsburg, Warriortown, and mines beyond, do they have a common source?
Do you know the answer to your question?
They do.
Yeah. So the question from a geologist in the audience is whether the other mines, Cornwall type deposits, do they have a common magmatic source? Lapham and Graham tried to figure that out. Lapham and Gray, sorry, for the Pennsylvania Geological Survey, tried to figure that out. And by the time their work was concluded in 1972, they were still puzzling over what was the source of the ore deposit here at Cornwall. So they didn't go beyond that. There are subtle differences between the trace element chemistry between the deposits of the Cornwall type. And so you would assume that there's a common source. But those differences get in the way of that common source theory. So there's probably more research to be done to test that theory and to confirm whether there is or is not a common source.
Most of those occurrences have some contact with carbonates.
Yes. Yeah, so the question was, did most of those iron deposits of the Cornwall type in the Triassic Basin, did the magma come in contact with a carbonate unit? And that is so. That's one of the features or characteristics of the Cornwall type deposit.
Well, obviously, there's been a lot of erosion since the Jurassic time.
Yeah, yeah.
Right now, several thousand feet, probably below landscape, but 100 million years. So theoretically, if these spills and dikes must have fed volcanoes at a higher elevation, and I suppose a lot of iron ore been lost.
Yes. So to repeat the question, the ore that is deposited here at Cornwall and also elsewhere in the Triassic Basin was deposited several thousand feet as a minimum below the current surface, the land surface. And so those magma plutonic rocks intrusions likely fed surface volcanic activity. And so there may be massive amounts of iron that are no longer present because that was all eroded off the ground surface. And that's true. We know that there were volcanoes nearby in the Jonestown area, but those volcanoes are a mid-oceanic ridge type volcanic activity. And so that predates the formation of these ore deposits by about 200 million years. Whether there were volcanoes in this area 200 million years ago, we don't know, because we don't have the evidence of those volcanoes any longer, because erosion has done its diligence in stripping off all those deposits. But where you see these kind of features today, you do see volcanic activity at the surface. So that would imply that you did have some sort of volcanic activity when the diabase intruded into the country rock here at Cornwall and elsewhere in the Triassic Basin. Is that fair? All right. Thanks.
Well, thank you, everyone, for coming out this evening. The conversation here at the end reminded me just a very short story. So years ago, there was a historian that worked for the Museum Commission. His name was Paul Wallace. Paul Wallace, Dr. Wallace, was also a professor at Lebanon Valley College. And he wrote this wonderful biography of Conrad Weiser. And one of my friends, a good friend of mine, Dr. Erwin Richmond, who's now high up into his 80s, was a young historian. And he and Paul Wallace were driving to Pennsbury Manor on the Pennsylvania Turnpike. And Dr. Wallace was a good generation older. And, you know, this was at a time where one rarely did 50 or 55. And I guess he was up around 65, 70. And Dr. Richmond looked over to his senior, Paul Wallace, who's driving, and said, Dr. Wallace, I think we're going pretty fast. And he looked down at the speedometer, and Dr. Wallace was a professor of literature. And he goes, oh, I'm sorry about that. I'm so glad we weren't talking about Shakespeare. We would have been well up over 90 by now, you know, because he wasn't paying attention. That's what something he really loved to talk about. So I know you in the room that like to talk about the geology. This is something that could go on. And of course, if you are more interested, I'm sure Mike will stick around for a few minutes after the talk. And also, of course, every Friday, or most Fridays, I should say. I don't want to chain Mike to the furnace. He's around to go ahead and give tours. So if you do have other questions, he's always real good about sharing his time, his talent, his information. So Thank you very much, of course, for joining us for this lecture. I especially want to thank Mike Weber for his presentation, for Kathy Donaldson, Bruce Chadbourne, and Lydia Jones for helping to organize our virtual talk. I also want to thank the Friends of the Cornwall Iron Furnace who sponsored the program, and the Cornwall Manor for allowing us to use this space. This is our last lecture for 2025, and we'll resume our lecture series starting in March of 2026. That schedule will be forthcoming. The museum's next event will be Saturday, December 6th, when the museum will have its Christmas at Cornwall event in conjunction with Cornwall Manor. We'll be offering guided tours of the furnace, light refreshments, holiday shopping, decorations, children's crafts, pictures with Santa, beer tasting, Revolutionary War history, and for an added cost, guided tours of the village of Anthracite, also known as Goosetown. So just a reminder that the museum is open Friday through Sundays for tours. So please check our website for details and for tour information. And if you are so inclined to be able to put these talks on, we do always appreciate donations. There is a basket in the back. If you happen to have a few extra dollars, we would certainly appreciate that to just keep this program going. So with that, I'll just say, please stay safe and have a good night.